So this unit will be all about looking at these functions called quadratic functions. Now, a quadratic is any polynomial where the biggest exponent is 2. For example, if you have an x squared in the equation. So we're going to be looking at a whole bunch of x squared functions and x squared equations in this unit. And like anytime I talk about a new particular type of function, I always think it's nice to start off by understanding the shape and what they look like when you graph them. If you got, some of you guys may remember this from Algebra 1. If so, you guys already, I guess you have a leg up. If not, the idea is that a quadratic, when you graph it, produces a shape called a parabola. Let's take a look at what they look like. So let's consider the parent function, f of x equals x squared. And to take a look at this, I'm just going to make a simple xy table. And when I make an xy table, I always like to use my standard -3, -2, -1, 0, 1, 2, and 3 x values, because I think it sort of gives you a nice overall picture of what the graph should look like. So I hope everyone understands what's how to fill out an xy table. You just take these x values here and plug them into the function. So if I plug in a -3 into the x squared, I get a 9. If I plug a -2, I get a 4. Plug a -1, I get a 1. Plug a 0, get a 0. 1, 4, and 9. And then with this xy table, we should be able to produce a decent graph, which again, we call it a parabola. Okay. So let's go ahead. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to try to do a 10 by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And then just go ahead and plot the points. So -3, 9 is up here. -2, 4 is right there. -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And then you just connect the points, and it is the familiar U shape that I hope, if we remember parabolas, create. Now, all parabolas have certain areas of interest that we are, well, interested in. Do note that in this particular parabola, it sort of has a low point. We say that the parabola in this case opens up, because notice how if you trace to the left, the graph goes up. If you trace to the right, the graph goes up. So I would say that this parabola opens upwards, and because it opens upwards, it has a low point. This special point we call the vertex. The second special characteristics of a parabola, you should notice, if my picture was completely accurate, if I was a computer like Desmos, I hope we can see that the graph is symmetrical, that the left side of the graph should be 100% symmetrical to the right side of the graph. You should be able to fold the yellow onto the blue like a book. And the line that splits this symmetrical shape, the dotted line that I'm drawing here, is called the axis of symmetry. And in this case, the axis of symmetry is at the equation x equals 0. One important idea when it comes to the vertex and the axis of symmetry, please note the axis of symmetry, which I'll abbreviate as AOS, always goes through the vertex. So that's a pretty neat fact, because if you know the vertex, you automatically know the axis of symmetry. It's just the x value. And vice versa. If you know the axis of symmetry, you automatically know the x coordinate of the vertex. Parabolas come into two flavors. I did say that this example, the parabola opens upwards. We could also have parabolas that open downwards. So openness of parabolas, and it's a very simple thing to understand. Parabola that opens upwards will be all equations or all functions where the x squared is positive. The only time you'll have a parabola that opens downwards is if the x squared is negative. So that's pretty simple and straightforward. Now, there are typically three variations or three ways you can write quadratic functions, and depending on which form I give you, I'm going to expect you to be able to produce pretty decent sketches of the quadratic. So let's talk about the three forms here. So three forms of quadratics. And the three forms are standard form, standard form looks like y equals some number ax squared plus another number bx plus a constant c. Vertex form is another form of a quadratic. It has the form of a times the quantity x minus h squared plus k. And the third form is intercept, also known as root, also known as factored form. It has lots and lots of different names. And that has the form of y equals a, x minus p, times x minus q. Right. Believe it or not, although these three forms, these three equations look completely different, they all paint or create the same picture. So how do I create these parabolas? How do I create these U-shapes if I'm given these three forms? Well, let's talk about them one at a time. So how to graph in standard form. The first thing you want to do is you want to find the x coordinate of the vertex by using this formula. X equals negative b over 2a. And what does the b and a stand for? Again, standard form is y equals ax squared plus bx plus c. Right. So that's what I'm referring to in terms of a and b. Once you have the x coordinate of the vertex, remember, this is also, little Jeopardy trivia fact, also the axis of symmetry, right? Once you have the coordinate of the x coordinate of the vertex, you want to find the y coordinate of the vertex by substituting x coordinate of vertex into your function. You're going to make an xy table using numbers that are close to the x coordinate vertex. And then last but not least, use symmetry to complete the picture. To complete the graph. Okay. So I know these steps would probably make a lot more sense when we do an example. So let's just go ahead and do an example. You know what? Actually, I'm going to change these bullet points into numbers just so it's easy to follow along. So let's call this step 1, step 2, step 3, and step 4. Okay. Let's take a look at an example here. Suppose I ask you to sketch f of x equals negative 2x squares plus 8x's minus, let's make this up, minus 7. I don't know, I'm just making this up. Alrighty, step 1. First thing I want to do is find the x coordinate of my vertex. The x coordinate of my vertex is going to be negative b over 2a. We just have to remember that in standard form, this is A, B, and C. So let's just plug in those numbers. Negative 8 over 2 times negative 2. That gives me negative 8 over negative 4, which gives me a positive 2. So step 2 is to find my y value. So all I have to do is take my answer here of 2 and then just plug it into the original function. So f of 2 is going to be negative 2 parentheses 2 squared plus 8 parentheses 2 minus 7. So that's going to give me negative 8. Just doing some quick math here, negative 8 plus 16 minus 7 is going to give me a 1. So what does all of this work say? All of this work says is that my vertex is at 2, 1. I plug in a 2, I get out a 1. So step 3, I'm going to make an XY table. Now technically for an XY table, you can plug in any number you want. My suggestion is start with your vertex. So I know my vertex was 2, 1, and then just plug in numbers that are close to the vertex. So since my vertex was at x equals 2, I'm going to pick numbers that are close to 2, say 3 and 4. I usually just do 2 more points, but you can do more if you want. So all we're going to do is take these x values, 3 and 4, and again, we're going to plug it into the original equation. So I'm going to sort of fast forward through the work, but I hope everyone understands that all I'm going to do is take these x values that I picked, and I'm just going to plug them into the x's here. So let's fast forward through this. If I plug in x equals 3, what do I get? I get a 9, negative 18. That's a 27, 9. So that's a, let's see, 27, negative 27. I guess I can't do this in my head. Negative 27 plus 24 minus 7. So that's going to be negative 3. Am I doing this right? Negative 9, negative 18. My bad. Negative 18. So that's going to be a 6 minus 1. There we go. And then when I plug in a 4, I guess a calculator would be helpful. If I plug in a 4, that's a 16, negative 32, plus 32 minus 7. That's going to be a minus 7 there. Okay. So once you have your table values, just plot it. And now the reason why I pick x values that are close to the vertex is it should make your y values reasonable. Technically, you can plug in any x value that you want, but if you go, too crazy, the y values might get too big. So I'm going to try to do a 10 by 10 here. 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And just plot it. So my vertex is at 2, 1. 3, negative 1 is my next point. And 4, negative 7, which is right here. Okay. Now this doesn't look like a U shape, but that's what step 4 is all about. So step 4 is to use symmetry. Remember we said that the axis of symmetry always goes through the vertex, and the vertex was 2, 1. So if you imagine a vertical line, you don't actually have to do this when you graph it on your own, but I'm just going to do it for the notes so you can see it. There's my axis of symmetry. So all of the black points should have a mirror image. So if I mirror image this point here, he should be over here. If I mirror image that point there, he should be over here. So there is our complete parabola. And it's an upside down parabola. We expected that because our x squared, where's our x squared? Here we go. Our x squared is negative. So that's basically how you sketch parabolas if it's in standard form. Use this formula to find the x-coordinate of the vertex. Once you have the x-coordinate of the vertex, plug into the original equation to have the y value, so that gives you a full point. Once you have the full point, just make an xy table around the full point. And then when you finally plot those full points, use symmetry to get the other side. So not too bad, I hope. If you can understand this, then all of the other formats are built upon this idea. And it's actually a cool thing because the other formats actually make sketching easier. Standard form will always be the hardest one to sketch because the other forms will give you information to start with. So how to sketch in vertex form. And if you forgot what vertex form is, it's ax minus h squared plus k. The reason why we call this vertex form is because it gives you what the vertex is. So the idea is that the vertex is always located at h comma k. Do note that in vertex form, this is a minus h, whereas this is a regular h. So these guys here will always be opposite to each other. Whereas the k, see how this is a plus k, a positive k, and this is a positive k? These guys here will always be the same. Well, once you have the vertex, it literally is the same steps as above here, standard form. So basically, if I give it to you in vertex form, step 1 and step 2 is already done. You just have to do step 3 and 4. Make an XY table and graph. Right? So let's go ahead and do a quick example here. So if I ask you to sketch, say f of x equals 3x plus 1 squared minus 5. So immediately I know that the vertex is located at opposite of this number, negative 1, comma, whatever this number is, which is negative 5. So boom, I didn't have to do any work. I don't have to do any formula. I know that's what the vertex is. And the moment I have my vertex, just make a XY table starting at your vertex. Negative 1, 5. Now, technically I can use any x values I want. I'm going to use x values that are close to my vertex. So since my vertex was at x equals negative 1, let's use 0 and a 1. Right? And again, I hope it's not a, I'm going to fast forward through this, but I hope everyone understands. All I'm going to do is take these x values and plug into the x here and see what I get. Right? So if I plug in a 0, I'm going to do some quick mental math here. That gives me a negative 2. If I plug in a 1, I get a 2, 4, 12. I get a 7. So let's go ahead and graph this guy. Since the numbers are less than 10, I'm going to try to do a 10 by 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then just plot your points. Negative 1, comma, negative 5. Ooh, that was weird. There we go. 0, comma, negative 2. And 1, comma, 7. 7, 7 here. Okay. And then just use mirror images to get the other side. Again, it's as if there's an imaginary mirror running through the vertex. You don't have to draw this dotted line, but I'm just doing it for the notes. And then just take the other 2 black points and mirror it over. So this point here would be mirrored over to here. This point here would be mirrored over to here. And thus we have our upwards parabola. It is upwards because this number in front is positive. So I think vertex form is the easiest one to sketch. Let's talk about the last form. How to sketch intercept form. It's also known as root form. It's also known as factored form. And if you forgot what that is, it's of the form y equals a, x minus p, x minus q. The reason why we call it intercept form, just like how vertex form gives you information about the vertex, intercept form gives you information about the x-intercepts. So the idea is that your x-intercepts are located at x equals p and x equals q. And just as with the h before, notice this is a regular p and this is a minus p. So they're going to be opposites to each other. These guys are opposites. And same thing with q and a minus q. These guys will be opposites. But once you have the x-intercepts, the x-coordinate of your vertex will be the average of your x-intercepts. And if you forgot how to calculate the average, just add them up and then divide by 2. Okay. And then once you have the x-coordinate of your vertex, just make an xy table, yada, yada, yada. You get the idea. It literally is, once you have the vertex, it sort of unravels itself. It's the same steps over and over and over again. I think this is a lot easier to see with an example. So suppose I ask you to sketch f of x equals negative x plus 5 times x plus 1. So we can see that it is an intercept form because everything's timesing each other. So I hope it's very easy to see that the x-intercepts will be the opposite of this number. So that's negative 5. And the other x-intercept will be the opposite of this number, which is going to be a negative 1. Right. So once I have the two x-intercepts, I know that the x-coordinate of my vertex will be the average of them because I know the vertex will always be right smack dab in the middle because parabolas are symmetric. So if I add these two guys together and then divide by 2, that gives me a negative 3. Once I have the x-coordinate of the vertex, I can make an xy table starting with the vertex and then just plug in x values that are close to it. Say, you know, I don't know, negative 4 and negative 5. So again, just take these x values and plug them into the original function. I'm just going to fast forward through this, but all it is just plugging and chugging. So if I plug in a negative 3, we get a, what? A negative 2 times negative 2. That's a 4 with a negative, so that's a negative 4. Plug in a negative 4, that's going to give you a, oh, what's this here? Negative 1 times a negative 3, which is positive 3. This will be negative 3. And plug in a negative 5, you get a 0. So make an xy table, or excuse me, make a coordinate graph. Here we go. Try to fit in 10 by 10. 2, 3, 4, 5, 6, 7, 8. I can only fit 8, but the y values aren't big, so that's not going to be a problem. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then just plot everything. Negative 3, comma, negative 4. Let's see, negative 4, comma, negative 3. And negative 5, comma, 0. This was the axis of symmetry. So then just plot the other points. Mirror image the other points. So I have another mirror image here, and I have another mirror image there. So go ahead and connect the dots, and there is your, oh, you gotta actually connect them, and there is your parabola. Okay. So what are the expectations of 4.1? The expectations is I can give you a quadratic equation in any of the three forms, right? In standard form, vertex form, or intercept form. I'm going to expect you to be able to produce a decent graph. The only thing I'm going to be looking for when it comes to the graph is, do you have the right vertex? Do you have the right overall shape? In other words, does it open up or open down? So go ahead and give that a shot. Give that a practice.